Okay guys, so in the last video we calculated the force of gravity between you and the Earth, and therefore the Earth and you. And the number we got was 587 newtons, about. So let's use that number to do some more calculations. So we found this force between you and the Earth. And the force of gravity pulling you down towards the Earth was 587 newtons. Which means that the Earth is being pulled up towards you with the same force, 587 newtons. So now let's think about what this means in terms of acceleration. So remember Newton's second law, force is mass times acceleration. And the force in both of these instances is 587 newtons. So if I wanted to figure out how much the Earth was accelerating towards you, I could rearrange this equation and say, well, acceleration is equal to force divided by mass. And we found the force using Newton's law of universal gravitation, so that was gm1 m2 over r squared. But we know that because gravity is a force, force equals mass times acceleration also applies. So let's find the acceleration of Earth to you. So to do that, we'll go 587 newtons and divide by the mass of Earth. 5.97 times 10 to the 24 kilograms. And that will give us 9.83 times 10 to the negative 23 meters per second squared. This is a really small number as well. So yes, sure, the Earth should be accelerating towards you at 9.83 times 10 to the negative 23 meters per second squared, but because that number is so small, it becomes basically negligible, especially when you think about, well, there's other people on the Earth too, and there's all these other things around. So the Earth won't really, again, just how we aren't pulled apart by distant stars, the Earth isn't going to start flying off because there's a few things around it that are small. What it will do is orbit around the sun. So the sun is very large, and because of that, it exerts a very strong force of gravity on the Earth, and that's why the Earth moves the way it does. But it doesn't really care about us just standing on it. So let's find the acceleration that you experience towards the Earth because of that same force. So all I'm going to do is plug in the numbers again. I actually didn't even need to erase that top part there. So if acceleration is force divided by mass, and the force was 587 newtons, and now the mass of you, 60 kilograms, and that will give us 9.78 meters per second squared. And I'll tell you that this number, if we used a little more precise numbers, would actually come out closer to 9.81 meters per second squared. And I'm only telling you that because this number should look familiar, whereas this number might not. And 9.81 meters per second squared is this number that we keep using for what? That's the acceleration due to gravity. Which means in the absence of air resistance, if you drop anything on the surface of Earth, it should accelerate downwards towards the center of the Earth at 9.81 meters per second squared. And so it's kind of reassuring that we got a number that was basically the same when we put in our numbers. So in fact, if you were to jump up in the air, you would be pulled down at approximately 9.81 meters per second squared. The cool thing about this is that no matter what number we put in for the mass of the object, as long as it's on the surface of the Earth, it'll still accelerate at 9.81 meters per second squared. And we'll go over that in the next video.